So we're here doing this drive today. I know everybody was really asking about it last time, so wanted to make sure we covered it going in. So this is a complete power assembly, ordered directly through York. Had it come straight from the factory. Comes with the whole setup, all complete assembly. You can technically buy the parts independently, which would be the inverter gates, all the capacitor bank, and then your SCRs, the rectifiers down here. But the cost for just those three main components was just a few grand short of the complete assembly. And the complete assembly comes with all your snubbers, the whole wiring harness, absolutely everything. So it was well worth for the customer to go ahead and invest in that. The warranty is not any different one way or the other. It's still just a 90-day parts, but still you get an entire assembly, and it's a lot more just plug and play. So what we've done so far is I'm going to go through. I just need to pull all of our power cables. I will pull all of our plugs and make sure we mark them so we get everything back in the right spots. And then on the back side here, this is part of the cooling circuit for this drive. So we've got it disconnected and pulled out. And then over there is the circulating pump. We've been letting it drain down. So we'll end up changing all the fluids out in this system, get it all fresh. And these will just slide through this back wall here. Pretty straightforward. There's two connections. You can see the other one right there. It's kind of right back around the other side of this conduit. Anyway, so the alternative to this is if we didn't do the whole assembly, which you can see it's got Allen there, Allen there. There's another one back there, and then one back there in that corner, so it's going to be fun to get to. Pull those four Allens, disconnect all the cabling coming into it, and this whole assembly would just slide right out. So the alternative to this was, just get the inverters, get the capacitors, and then change all this out and try to reuse the old mounting assembly, which was really the only thing that would be left by the time it was said and done. But like I said, it wasn't advantageous for the customer. So I will keep y'all updated as we go through this, and I'll see if I can set the camera up somewhere we can get a good time lapse of yanking this thing out and getting it back together somehow. There's not really a real good spot to set the camera up with a tripod that's not full of wires. Alright, so far I've got all the power whip assembly pulled. I'm taking the last mounting bolt out now. I've already got our back disconnected on our cooling circuit. All these cables will be new with the new assembly. Now, got our ground unhooked. Should be able to just pull it, feed it through these grommets. And the new, if you buy the whole assembly, the grommets come with it, so we don't have to worry about reusing those. leaking. There it is. So, we're ready to go back in with this one. Move those plugs, pull these grommets back. Away. Put this stuff in. Voila, they're in the back. We got everything there. Compressor lines are up here. I would just, so what I'll do, get our 4 mounts in, reconnect all the wiring, make sure all the shipping tape, like on this crap over here, is off. We'll just reconnect everything, tighten it all down. I need to change 2 of the fuses. So we'll change those fuses out. You can see these 2 are popped. Got the little red button sticking out. And we'll be ready for startup. Has a 3/16 Allen. These for that. And take care of our plugs. Actually, look at that. I got them all labeled for us. 1, 2, 3. So the way this drive lines up is right to left. 1, 2, 3, 1, 2, 3, 1, 2, 3. So everything feeds in to one central source, going through your SCRs, charges a centralized capacitor bank, and then feeds 2 independent inverter gates. Okay, so this is compressor 2, compressor 1. I'm sorry, I got that backwards. Compressor 1, compressor 2. That is feeding here. And then what it does is it can control just one compressor off of the gates and have this one shut down, and then say this one ramps up fully and it's not able to carry the load, it wants to bring the other compressor in. What it'll do, and it'll freak out if you don't know what's going on, you'll hear this compressor stage up, and then all of a sudden it'll just take a nosedive and come down. And then you'll hear the other compressor engage, and they'll both lock in, and they'll both start coming up together at that point. That way it can properly stage the control and keep everything, you know, uniform in the system. So if you're ever working on it and you hear that, you know, I have guys help me out all the time, and that gets them every time. I'll be talking to them on the phone, and they'll hear that they'll hear that compressor take that nosedive, and they'll think they pushed the wrong button. In reality, it's just doing what it's supposed to do.
Huh?
So most people think, you know, this is a transformer the first time they see one, and while it does have a striking resemblance to one, that is not what it is. So that is a line reactor or a line filter, depending on, you know, who you ask. It's all the same thing. Its main job is to basically clean up the voltage. Helps take a lot of abnormalities out. It literally filters it, just like like I say, it's a line filter, a line reactor. What it's doing is, as it's flowing through, and the voltage around the cores that are in here, there's 3 independent cores. As it flows around those cores, much like a transformer, help induce a lot of the irregularities out of the current. So it helps purify it going into the SCRs and then hitting your capacitor bank. Most all of your drives built today have a line reactor of some kind in them. It just may look like a really large transformer, or it may look different. Like I said, this is a very large reactor for this drive because it's a large drive, right? But anyway, this is pretty standard on almost all VFDs produced today. It's going to have some form of line reactor built into it so that it can better filter that power coming in to make it more pure for the system, because these components, they do not tolerate poor power. They don't tolerate inconsistencies. That's the fastest thing that tears them up every single time. And so the better and cleaner the power you can give them, the more life and sustainability you're going to get out of them. Which is one problem we have here in Austin that drives us crazy, is we've got extremely poor power, and I'm constantly having to service these VFDs all the time. I've got another one on a train centrifugal. Same thing happened to the rectifiers and the inverter assemblies both just took a dump. because of incoming power. So now we're trying to decipher, you know, get them set up on what we're going to do for them. So these are all just things to know, to be prepared for, and you know, just greater understanding. Okay, well, we still got to hook the cooling circuit back up. We do need to tighten down the line reactor here. Still haven't got that done yet. Do that next. So that gets all of our power connections, all of our control wires plugged in. Now what we'll do is we'll hook up the cooling circuits, get those attached back. We'll change those fuses out, and then we'll finish dumping whatever water we can get out of the coolers back out the rest of the way. We'll fill it back up, get everything turned on. Yeah, it's one of the things that...
Did you test those line filters?
This?
Yeah?
Yeah.
You did? Oh.
Yeah. So when I tested this, I ohmed it across, and it was 0 ohms, which is good. And then I ohmed it. Actually, I ended up mega ohming it to ground, and it tested good on mega ohms too.
All 3 of them?
Mm-hmm.
Okay.
That's where it's solid.
Now, how do you know that this ain't gonna blow again when you turn it on?
We'll turn it on.
That's just...
It's just the way it is.
Okay.
Yeah, I mean we can only move forward with so much certainty before. Now we're just guessing. So
That's a $30,000 guess.
yes, sir, it is.
That doesn't scare you?
Get used to it. That's why people are scared to get into chillers. Not gonna do, you know. Most of my jobs, you know, you're talking anywhere from $10,000 to $100,000 worth of stuff, if not more sometimes. It is what it is. Just gotta do it. So you just gotta trust your instincts, trust your experience, what you've been through, what you've seen, the training you've gotten, and do the best you can. At the end of the day, you do all those things and something still goes wrong. I mean, you gotta make it right, but you did everything you could.
So what is the purpose of these fuses?
These are to protect the drive assembly.
So they're first line of defense?
Yes, sir. Because while this is technically, it will trip as a breaker, it's not as sensitive, I guess.
So how come the power surge got past those?
Past this?
So it tripped the breaker, it blew the safety fuses, and it fried the drive.
Right.
Was that just an extreme amount of power?
Mm-hmm.
Is that a lightning bolt?
It could have been. It could have been lightning, could have been a brownout that caused a weak incoming power, and it had that happen so many times that those gates just couldn't take it anymore, so they ended up shorting out. It could have been Yeah, I mean, if you had either a surge or you know, even like you said, a lightning strike, that would have caused a major surge on the system, and that could have hit it.
So if those safety fuses blew and the power got to the drive and overloaded the drive, caused it to fail,
I think it's more likely that the drive got hit and blew everything else. So I think the drive was what caused everything else to blow.
very cool. So the drive just went bad.
And then it becomes a question of, well, why did the drive go bad? And then we get back to start talking about, you know, either power surge, whether it's lightning, whether it's the grid, whether it was a brownout.
Or the drive was 12 years old.
Exactly. Yes, sir.
So when a capacitor goes bad and it overloads, will it send power back up the line?
Back up the line and back towards incoming?
Back toward incoming, yeah, toward the SRCs.
No. So if the capacitor goes bad, it's either going to short internally, which inevitably end up causing it to turn into a fuse and blow. It's not meant for that. Which is kind of what happened to one of those capacitors. So it, you know, if you saw the previous video, it had one of them was cracked. You know, that capacitor was still testing good, so it hadn't shorted internally, but it had been overheating. That's the reason why it split like it did, and it started venting all the pressure it was generating inside because it had began to fail. It just hadn't fully failed yet. We caught it in the early stages of failure.
What does a capacitor do when it fully fails?
Like I said, it either just quits working altogether, just goes open line internally, or it will short itself out, which when that happens, it can literally turn into a grenade and just go boom. So when you walk up to drives, and I occasionally have them. I had one, I think about 2 months ago, as a condenser fan motor drive. Literally, I opened up the drive panel, and the hole had about a half of a fist size hole just blown out the drive, where it had something, it shorted internally and the capacitor was overloaded and just literally shot it out like a grenade.
Wow. That tank that's in the cardboard box, you call that resistor?
Inhibitor.
Inhibitor.
That's the factory term for it. Really and truly, it's radiator fluid. End of the day.
Antifreeze.
Antifreeze.
Okay.
End of the day. But they used to sell it in a concentrate where you'd have to mix it yourself, just
That's
like
right.
you do with antifreeze. But nowadays they just sell it all pre-mixed. You actually see it. Most of the time it'll say, yeah, it says there on the box, yellow tag, pre-mixed. So it says do not dilute. So yeah, but anyway, that's all it is. It's just antifreeze. But it's their own specific blend for their specific makeup. So like, you know, antifreeze in a car, it runs at a really high temp and runs highly pressurized, and it's going through components that aren't overly sensitive. You know, you're talking about the block of the motor, maybe a heater core, and then the radiator itself. And so, you know, you don't have a whole lot of bacterial issues, or, you know, you're not talking about sensitive equipment at the end of the day. The reason they have and they've gone through over the years several different versions of their inhibitor, because they've had bacterial growth issues, they've had a lot of issues, and they've changed their policies on how to handle their inhibitors and what to do for the annual maintenances for them. Because that's what it's doing. It's cooling this whole cabinet through this cooler, this heat exchanger, and running these fans. But it's also running through, and this is the most critical part, this isn't overly sensitive. This can take a little bit of a hit and it'd still be fine, it would work. But this cooling plate for the drive, it's very sensitive, and you start getting a lot of corrosion and buildup or anything internally inside of those plates, and that's it. This drive's going to start overheating, it's going to start having problems, and it's going to end up shutting down on you, and you're going to end up frying the drive because you overheated the drive.
So can I come up here and test that plate and see what temperature it should be?
You can do it through the control panel.
The control panel will tell you what the cooling plate is?
It'll give you a readout. It's got thermistors in here. That,
and do you know offhand the temperature, the range it should be at to be safe?
See if I can remember. I think they're supposed to maintain below, I think it trips out at 160 top end. I think they want them below below 120 or something like that. I have to verify through the manual, but it's something in that ballpark.
That's really hot, 160. Is that solid copper?
Yes. Yes, sir.
There's no torque specs on those?
There is. I got my torque wrench. No, there's definitely. that's it, guys. Sorry about the mix up there on the video. I ran out of storage space on my phone, had to clean some up, but went ahead and finished everything up. We've been staging off and on. I started having some control system issues on the building, but they're getting that straightened out now. But the drive's working perfect. Both circuits are staging exactly like they're supposed to. It's catching up the building load. We look great. Couldn't ask for a smoother, cleaner job. Yeah, and that's all it is. You know, like I said, we were able to purchase that whole assembly. You can buy it independent pieces if you needed to. But it had so much damaged on this one that it just was not worth doing anything else with. So you know, I just am going ahead and you know, we're not fooling with it, not going to try to do anything with it. Just let it go, leave it be. They're going to hang on to it just in case. You know, maybe they salvage a part at some point in the future. I'm not sure, but anyway, another job done. We'll move on to the next one. Hope y'all enjoyed this.